7.2, just prying into things, from page 134 to 139 of your Science Connect 1 textbook. Levers are another simple machine. A lever is a bar that pivots on what's called a fulcrum with the goal of moving a load with effort or force. So we can see that a fulcrum is where the lever balances. So kind of like on a teeter-totter, if you would, where that bar is balanced. The load is, of course, what we are trying to lift or pry or move with the lever. The effort is where we are applying some sort of force. The load distance is the distance from the fulcrum to the load. So in this diagram, our load distance would be here, and it's usually to like approximately the middle of the load, if you will. And our effort is from where our effort is applied to the pivot point of the fulcrum. So that is our effort distance. How we change these distances, whether which one is longer or shorter, or if they are equal, helps to change what the lever does. So it might make it easier to move or harder to move based on these distances. There are 3 types of levers. The difference between these 3 types is where each of these pieces is located. So where the load, the effort, and the fulcrum are within the lever. A first-class lever, the fulcrum is in between the load and effort. So it's what we just saw here. We have a fulcrum, the load, and the effort. So examples, prying anything open. Like I can see a hammer here. We have the fulcrum is our pivot point here. The load is the nail we are trying to pull out, and the effort is on the top of the handle. So we can see that it went load, fulcrum, effort, and that would describe a first-class lever. In our scissors, looking at one handle, one piece of the scissors, we can see that the effort is located at one end. In between the pivot point where the scissors are connected is the fulcrum, and the load is what we are trying to cut. In our pliers, we are exerting a effort or input force, if you will. Here, our fulcrum is where they are connected, and the output force or the load is at the other end of this piece. So prying anything open, lifting something with like a pry bar, if you will, or kind of like a teeter-totter. Pliers, scissors, the claw on a hammer, all of those are examples of a first-class lever where the load is at one end, fulcrum is in the middle, effort is at the other end. In a second-class lever, the fulcrum is at one end, the effort is at the other, and the load is in between. So if you want to draw something like that, fulcrum is at the end, load is in the middle, and effort is at the other end. So an example is a wheelbarrow. We pull up on our handles, the load is in the middle, and the fulcrum, where it pivots, is at the wheel, so at the end. Over here, we have a nutcracker, or you could think of like a garlic press as well. The effort is at the end. The load, what we are trying to move or crush, is in the middle, and the fulcrum, the pivot point, is at the end. In our stapler, it's harder to think about, but the load is in the middle. The force is right on the end of our stapler. If you press at the very end of the stapler, it's a lot easier than if you press closer up here. And the fulcrum, the hinge, is up here. In a bottle cap, we have the effort here, pulling up on our bottle cap. We have the load, the bottle cap itself, and we have the pivot point, the fulcrum at the very end. So those are some examples of our second class lever, which is a fulcrum, the load in the middle, effort at the other end. A third class lever, the fulcrum is at one end and the load is at the other. The effort is in the middle. So if we were to draw this, we would have fulcrum, effort, and the load at the other end. So some examples of this are a hammer. Our effort or load is what we are trying to apply force to, so our nail. The effort is from the handle, that's where we're gripping it. And typically we're swinging from the end, so the end would be our pivot point or our fulcrum. Some other good examples are tongs or tweezers. The fulcrum or the pinched end is at the end. The effort, we apply the effort in between. The load is what we are trying to grip at the end. A broom, when you're sweeping back and forth, if you were like Cinderella, the fulcrum is at the top where it kind of pivots from. Our effort, where we hold it, is in the middle, and the load, what we're trying to sweep, is at the bottom. A fishing rod is also considered a fulcrum if you were to cast. So a third class lever if you were trying to cast. The fulcrum is the the handle end of our fishing rod because it doesn't move very far. The effort, where we are holding it, is in the middle. The load is the end, the hook itself. So some other examples: an axe, any sort of sports racket, a hockey stick or a baseball bat. We've looked at the broom, the tweezer, the tongs, and the fishing rod. There's also levers in our body. These are depicted on page 138 as well. So our head tilting forward and back would be an example of a first class lever. This is because the load, the weight of our head, is in between the pivot point in our neck, and we are applying a force using the back muscles of our neck. Okay, so this is a first class lever. We have a second class lever. The load is between the force and the fulcrum in our foot, so kind of our Achilles lifting our heel. We are pivoting on our toes. The load is our weight, and the force that is lifting us up is our calves, so like a calf raise here. A third class lever would be our bicep. The fulcrum is our elbow. The load is what we are, of course, holding. And in between those, the edge of our elbow and our hand is our bicep. If you were to look at this, what would be the difference if we were doing a tricep? Well, our applied force is over here. Our load is at the end, the applied force is at the other end, and the fulcrum is in the middle. Therefore, using our triceps versus our biceps would be a class 1 lever. A distance multiplier moves a load through a large distance, but requires a short effort distance. So third class levers are common, and I've chosen a golf club here. If you think about the effort where we hold it, that would be the handle of our golf club. When we swing, the effort or the handle doesn't move very far. It has a short effort distance, and that is in comparison to the golf club itself, where we're striking the ball, it moves a much greater distance. This provides a speed advantage. The load end moves fast because it moves a far distance in the same amount of time, whereas the effort moves at a slower pace because it moves less distance over the same amount of time. So a distance multiplier is where the load end moves a long ways and the effort moves a short ways in the same amount of time. A force multiplier is a simple machine that easily moves a large load. So we use a small force or effort to apply a large force on our load. When the effort distance is large and the load distance is small, this is going to work. So we can think of a pry bar. We put a pry bar really close to what we are prying out, whether that is the claw on a hammer or a pry bar in any other kind of situation. The pry bar itself is quite long. We are going to pivot close to the load, leaving a large effort distance. These are typically our first and second class levers. So you can think even in our wheelbarrow, the handles are longer and our load sits closer to the wheel, the fulcrum in this point, so that our effort distance is large. There's some practice. Page 139, numbers 1, 2, 3, 4, 5, and 6 would be really good practice because we have 3 different types of levers to look at. There's a little bit of extra practice here today.